Hello everyone, Victor here. So today we are going to revisit the Quiz 2 problem 3a, which is find the equation for a hyperplane that passes through the points, these 4 points. Alright, so to do that we need this equation. Alright, so this is the general form of the equation of a hyperplane that is in a 4D space. Alright, so but today we are not going to talk about hyperplane. Instead, we are going to talk about how do you solve a system of linear equations. So what do we have here? Now what we have is 4 points. So we know that for this particular equation to fit for all of these 4 points, when we plug that in, they should all add up into 0. So right away we have 4 equations, which is minus a, we have plus b, we have plus 7c, and plus 2d's, and then plus an e equals to 0. So that's coming from the first point. Alright, so similarly we have 2a plus 3b plus 2c minus d plus e equals to 0. Okay, that's the equation coming from the second point. And similarly for the third one we have this one we have plus ac minus ad and plus an e equals to 0. And for the fourth point we have a plus 10b's plus 2c's plus 2d's plus an e equals to 0. Okay, so right now notice that we actually have 5 unknowns, right? And we have only 4 equations. Now just keep that in mind that we have 5 unknowns. We want to find out what a, b, c, d and e are, and we only have 4 equations to do so. Alright, now here is the step. So first of all, this is what we call a system of linear equations. Alright, a system of linear equations. We have 4 equations in this system. So what are we going to do is we are going to eliminate as many unknowns as possible as we go through the process. Alright, so here let's say our first objective will be to eliminate the unknown a, so that we will arrive at a different system of linear equations without a. Alright, so to do so we need to do some tricks. Okay, now let's make it simpler. Let's say this is equation number 1, this is equation number 2, this is equation number 3, this is equation number 4. Alright, so what we are going to do is, notice that if I add this equation number 1 2 times to equation number 2, I actually can cancel out the first unknown, because if I add like 1 minus a, 2 minus a to these 2 a's, I actually cancel them, right? So this is what I'm going to do. I am going to add this equation 1 2 times to this equation number 2, right? Add 2 times. Right, so what I have here is from these 2 equations, but by adding 2 times I have 5b, right? And then I have 16c, I have 3d's, I have 3e equals to 0. So essentially what I'm doing is I add this equation number 1 to equation number 2 2 times, right? So I arrive at this equation. Right, now for the third equation I don't have to do anything, because automatically there won't be any a in the equation, so I just copy it. So I have c, d and plus e equals to 0. Alright, and for the fourth one I only need to add equation 1 onto this equation number 4, and then I cancel out the unknown a, right? So that's why I have 11b, I have 9c's, I have 4d's, I have 2e's equals to 0. Alright, so right here what we have is we have 4 unknowns left, right? Because I've just eliminated A, and I am left with 3 equations. Now notice that I can't have more than that, because if I add the first equation back into any of these equations, I will somehow reintroduce A back to the system, right? So it doesn't work. So that's why I have a kind of like a new system of linear equations generated from the first one and without the unknown A, right? With one unknown less. Alright, next. So here I'm just copying what I have in the first slide. So I have 5B's, I have 16C, I have 3D's, I have 3E. This one is my first equation. I have a C, I minus D plus E equals to 0. That's the second one I have. And I have 11B, I have 9C, I have 4D's, and I have 2E's here. So what I have here is a set of 3 equations. Now the next step is I'm trying to eliminate the second variable, that is B, or unknown B, right? So notice that from here, if I somehow like add or subtract how many times I wanted, I cannot do it, because there's no way I can like completely eliminate these 11 B's, right? So what are we going to do? What we are going to do is we are trying to bump up both of these coefficients, as we say. So to do that, let's take a look at the least common multiple of 5 and 11, which is 55. That is to say, if I bump up this coefficient 11 times to 55, okay? So if I multiply this whole thing 11 times, I get 55B, right? And if I bump it up, like multiply it by 5 times, okay, oops, then I have 55B as well. So I can actually eliminate, cancel out each other. So this is the next step I'm going to do. I am going to have 11 copies of the first equation and then subtract 5 copies of this equation, right? By doing so, I basically cancel out all the B's. Of course, the rest have to be stay there. So I have 11 times 16, which is 176 B's. And then I actually do a minus here, so I'm subtracting 45, that is 5 times 9 C's, right? And I have 33 D's, and then a minus 5 times 4, it is 20, and this D, this is D, and of course I have 33, and then minus 10, like that. Okay, so if I do some arithmetics, I have 131, I have this one is 13, this one is 23, right? So I basically get like a new equation without B. Of course, if I look back to this equation, it doesn't have B in the beginning, so I just copy it right here. Right, so what we have here actually will be 3 unknowns, right? 1 less unknown, and I have 2 equations left. All right, C, D, E, 3 unknowns and 2 equations. All right, let's go to the next slide. So once again, I copy what I have from the previous slide, which is 131C, and then plus 13D, and then plus 23E. Right, and the next equation I have is C minus D, and then plus E equals to 0. Now, of course, this is like similar. I have a system of linear equation with 3 unknowns, 3 unknowns and 2 equations. And what I'm going to do here is I'm going to eliminate the unknown c. So this is simple. This time I only need to subtract this equation 131 times from the first equation. Then I can get rid of the unknown c, right? So that's why I have 13 and then plus 131d, and then I have 23 minus 131e equals to 0, right? So this one gives me 144. This one gives me minus 108, right? And if I rearrange the terms, I have d equals to 108 over 144 e, and then if I cancel the terms, I have 3 over 4e. Okay, now here at this point we have two unknowns and one single equation, and that's the end, because there's no way I can generate further equations from just one equation, right? So what we have here is d equals to 3/4 of e. Okay, now the next step is we roll back. That is to say, we want to express c in terms of e only. So if you look back to this particular equation, we have c, d, and e, right? So if we plug the d in terms of e in, we have c minus this one, and then we have plus e equals to 0, right? So this gives me c equals to minus 1/4 of e. Alright, now similarly, if you look back to one of the equations from the previous slides, you actually get one of the equations like a 5. Remember, we have like a 5b, we have plus 16c, we have plus 3d, we have plus 3e, right? Equals to 0. So right now I'm going to put b on one side. I have minus 16c minus 3d minus 3e over 5, right? So next thing to do is to plug in this one, and then plug in this one, and then you will get b equals to minus 1/4 times e. Alright, so with that, if you go all the way back to like the first equation in the beginning, you can actually find a with a similar method, which gives you 2/4 of e. Alright, so here I'm just copying what I have from the very last like one single equation of with just d and e. I have this one, d equals to 3/4 of e. I also have from one of the other equation, I have c equals to this one. I also have b equals to this one. I also have a equals to this one. Alright, so if I plug right back in the equation in the very beginning, I actually have this one. This is a x1 plus this one x2, so I just use the minus sign, and then x2, and then minus, this is c, and then this is d. Of course there's an e here, and then they all add up to 0. Okay, now but this is not the answer yet, because I still have an unknown here, right, the e. So what are we going to do about it? One way to do so is we imagine c can be any value. We can notice that if e changes, a, b, c, d will also change accordingly, right? So it doesn't matter if e has a different value, it doesn't really matter. So to make it easy, we set e equals to 4, so that it will cancel this denominator for each of the terms. So let's say e equals to set e equals to 4. Alright, so this one will become 2x1 minus x2, and then minus x3, and then plus 3, oh, missed the x4 here, sorry about that. So we have 3x4 and then plus 4 equals to 0. Okay, now if you set e to some other values like 8 or -2, it will still give you the same result actually. So don't worry about like picking the other value of e. To look at it in a different way, you can actually factorize e out, because each term has an e, factor e, and then you simply divide the whole thing with e, and then you will get the same result right away. So there you go, we have actually solved the system of linear equation by finding a, b, c, d in terms of e, and then plug all back in and find the equation of the hyperplane, which is the answer. And then you know how to solve that right now. So I hope you can learn something from it, and I'll see you next time.